We are continuing with the discussion of the various reaction-based questions in the paper. And in this video, we'll be discussing the one 2020 and the set 3. Again, I've gotten this paper from iitnacademy.com to check out their website for all the question papers, and they have a lot of it. So let's start. This question number 13. So they've given us a compound. And this particular compound, when it's heated with chloroform and alcoholic KOH, gives us the foul smell of water. And based on the reactants of this particular sentence, or in this equation, it's obvious that it's a carbylamine reaction. Carbylamine reaction is what you've learned in amines, and basically you get isocyanides or carbylamine from amine. So when we have this particular compound, carbylamine, I think, reacting with CHCl3, as chloroform, in the presence of alcoholic KOH, it gives us carbylamine. So you have the NH2 group shifting to give us a CN group, or NC group, sorry, isocyanide. And plus 3KCl, oh, I'm sorry, plus 3KCl plus 3H2O. And I would like to write the general reaction, that is RNH2 on reaction with CHCl3 plus 3KOH, and on heating gives rise to RNC plus 3KCl plus 3H2O. So this is the carbylamine reaction, and based on the product that we've gotten over here, this is the answer, option B. So, I mean, it's not a direct reaction-based question, but it's related to a chemical reaction, so I thought it would be good to discuss it in this video. The next one, they've given us these three reactions, and we're supposed to write the major products for the following. So we need to write the major products for these reactions. So let's start with the first one. So when you have a chlorobenzene, and this particular molecule is reacting with concentrated H2SO4, and it's being heated. So when we talked about, or when you've learned about the haloarenes, one of the major or most important reactions, or I wouldn't call it important, but these are the reactions that we learn about aryl halides, and that is electrophilic substitution reaction. So in this case, you have concentrated H2SO4, which obviously means sulfonation reaction is taking place. So you have the possibility of two products being formed, and they only want us to write the major product. So one of the products, because this is an electrophilic substitution reaction, you have the formation of an SO3H, or an attachment of the SO3H group to the ortho or the para position. And I'm pretty sure at this point you know why a haloarene is undergoing an electrophilic substitution reaction. So first, the ortho product is going to be this one, which is 3-chloro benzene sulfonic acid. This is possibility number one, and this is the ortho product. The other one is obviously going to be the para product. And you have a Cl and then the SO3H. And this is 4. I'm sorry, this is 2. It's actually 2 chlorobenzene, I'm sorry. This is going to be 4 chlorobenzene sulfonic acid, and this is at the para position. Now, between ortho and para, this particular electrophilic substitution reaction prefers the para one because of the steric reasons. Because of that, the para product is going to be the major product, whereas the ortho is going to be the minor product. The next one over here is you have this compound undergoing a chemical reaction with HCl and heat. CH2, OH, OH, and HCl. So obviously, based on the the reactant, that is HCl and heat, it's obvious that you have a replacement of the OH. Now, this is based on the chemical reaction ROH on reaction with HX gives rise to RX plus H2O. And this is in the preparation of haloarenes or alkanes from alcohol. So in this particular molecule, the OH group, which is attached to the CH2, is the one which is going to get replaced. Now, if you think about it this way, the Cl will have, when it comes and attacks, let's assume, it's coming and replacing the OH. It's removing the OH and it's basically kicking this out and getting out of here. But in this case, when the chlorine will get attached to this one, this OH, it cannot, the benzene itself is going to have a negative charge, and it will become slightly difficult for the chlorine to eliminate this OH group. And because of that, your product for this particular reaction is going to be without the replacement of this hydroxyl group with the chlorine, but the other one is going to get replaced and you'll get a CH2Cl. The third one over here is we have been given this alcohol and it's undergoing a reaction with copper. So copper and 573 Kelvin. Now this reaction is again, it's from alcohol, phenols, and ethers, and it's an example of the oxidation of alcohol. Here we have a tertiary alcohol, right? So you have this carbon atom attached to 3 other carbon atoms. So it is a tertiary alcohol. And this on oxidation is going to give us an alkene. So the OH is going to get kicked out as water, and you'll have a double bond with one of the other carbons. So C double bond CH2 CH3. So 1, 2, 3, 4. 1, 2, 3, 4. And OH and another hydrogen atom are going to combine to give us water. So with that, we're done with question number 31. Now let's move on to the next one. Next question. Here we've been asked to write the mechanism. I'm pretty sure you know how to write that by now. This is the formation of ether, and if you do not, if you find writing this one little difficult, I have a video where I just discuss the reaction mechanisms for alcohols, phenols, and ethers as a chapter. So let's get to question number 32, part B. So here we need to show how phenol is prepared from cumene. So first of all, cumene, you need to know what the molecular formula of cumene is, which is CH, a benzene ring with a propyl chain attached to it, 3-carbon chain, and this is giving us phenol. Now, this particular reaction is actually just a direct reaction of preparation of phenol. You have it in your textbook. It's just going to be about you being able to recall this particular reaction. So you have cumene. And for ease of writing, I'm just going to write like that. Reacts in the presence of O2 to give us cumene hydroperoxide. So what's happening over here is the hydrogen atom this hydrogen is getting replaced by an OOH, and it's not COOH. I will write that, but since the product is, or this particular compound is called a hydroperoxide, you have an OOH. So this is cumene hydroperoxide. Now, this is undergoing a reaction in the presence of an acid. So H plus H2O, it is giving us a phenol, which is our major product, which is the product that we wanted rather, I'm sorry, and the CH3COCH3. So these are the two products, and this is a basic reaction that you've learned, and this was just directly asked from your textbooks. The next reaction or the next question is, how do we convert the following? And this is the OR part of the same question. So I'm just going to mention that. And we have to convert sodium phenoxide to orthohydroxybenzoic acid. Now, sodium phenoxide, orthohydroxybenzoic acid, all of these are such complicated names. So let's just draw the structures first. So sodium phenoxide is basically O and Na, which is a hydrogen has been replaced by a sodium atom. And this has to be converted to orthohydroxybenzoic acid. Now, the reason it's orthohydroxy is because when you have a COOH, and between COOH and an OH, that is a alcoholic group and an acid group gets more priority. And because of that, it becomes part of the parent. I mean, it becomes the part of the parent chain, or its name is considered, the functional group is the main functional group. So this is our product. So basically you have the ONA, and this getting this particular position, you have a COOH group attached to it. Now, this actually is not a direct reaction. So this is based on the Kolbe's reaction. When you have the Kolbe's reaction, you have a phenol on reaction with sodium hydroxide is giving us sodium phenoxide. And this on a further reaction with carbon dioxide followed by water is going to give us the product that we need, which is orthohydroxybenzoic acid. So again, this is the direct reaction, but you would have had to have thought about the fact that it's the second part of the Kolbe's reaction. Also, this particular compound that we've gotten over here is called as salicylic acid. The next one here is acetone to propene. So acetone is CH3COCH3 is giving us propene, CH3CH double bond CH2. So how did this get converted to this? So this is again from alcohols, phenols, and ethers. So what happens is when you have you need to figure out a way for us to convert an ketone to an alkene. And from your from whatever you've learned till now, there is no direct reaction in your textbook where you convert a ketone to an alkene. So we will be converting this ketone to an alcohol and then converting the alcohol to an alkene. Because if you remember, an alcohol can undergo a dehydration reaction to give us an alkene, and a ketone can undergo a reduction reaction to give us an alcohol. So what we are doing is we're converting CO to give us a COH, and this is then going to give us a C double bond C. Basically a C double bond, so I'm not just okay. So C double bond to another carbon atom. So this is the plan. So when CH3CO CH3 is undergoing reduction reaction in the presence of LiAlH4, which is a reducing agent, it is going to give us CH3, CH, CH3, and to this, you have an OH group attached. 1, 2, 3, and 4. So the valency is also okay. Now, this is actually the oxidation. Sorry. So this is a reaction where you have the preparation of alcohols. This is actually in that chapter. So alcohols, phenols, and ethers. And then this particular compound on further reaction with 85% H3PO4 at 440 Kelvin is going to undergo dehydration. So a water molecule is going to get kicked out. So you get CH3CH double bond CH2 plus water. And since it's a secondary alcohol, it requires milder conditions to undergo it requires milder conditions to undergo dehydration reaction. So that's about it. The next question over here is phenol to chlorobenzene. Okay. So phenol to chlorobenzene. So Cl group chlorobenzene. So what happens is we can't, as it's obvious right now, we can't just use HCl and heat and just replace this with this. So phenol has to undergo a chemical reaction for us to get something else that can get converted to this particular compound. So what we're going to do is we're first going to convert the phenol to a benzene. So we're just kicking out the OH by reaction with zinc. So when that happens, it leads to the formation of a benzene. And this particular reaction is a reaction of phenol with zinc dust. The second part is where we have to convert this to this, that is benzene to chlorobenzene. And this particular reaction, you can just react the benzene molecule with chlorine, iron, and dark, or we can use FeCl3, and this in turn is going to give us chlorobenzene. And this is one of the methods of preparation of haloarine from hydrocarbons by electrophilic substitution reaction. With that, we're done with these two questions. Let me first erase all of this. I feel like if you have a basic idea regarding the various chemical reactions, and if you are confident enough to just remember, or if you're able to remember all of them, you should be able to solve all of this on your own. And even if it seems like it's slightly difficult, you can just recollect, you will be able to remember. But ideally, what I'm realizing nowadays is that it's easier to remember it chapter wise, if that makes sense. Or if chapter wise is also too hard, you can remember it by the functional group. So that when you think about a particular chemical reaction, and if you're asked to convert this to this, it makes it all the more easy for you to solve such questions. Let's do question number 33 now. So we're supposed to write the products when, oh, sorry, it's on the eraser. Okay, when this particular compound reacts with various reagents. Now, the first one, if you notice the reactants, and you would have realized that it's a pretty known reaction. So CH3 taken thrice, CCHO. So this is an aldehyde, and important to remember, it does not have a beta hydrogen attached to it. So when this particular molecule, I'm going to open the structure up. So CH3, 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 CHO reacts with this, that is CH3COCH3 acetone, in the presence of dilute sodium hydroxide. So this is the aldol, or in this case is the cross-aldol condensation reaction. So you are having this particular hydrocarbon, that's a ketone actually. You have a ketone which has 6 alpha hydrogens, and you have an aldehyde with beta hydrogens, I'm sorry, 6 beta hydrogens, whereas the aldehyde does not have any beta hydrogen atoms. So this is going to be a cross aldol condensation. And usually for such reaction, what I like to do is open the structure up so that it's easier for us to write the products. So let's start with the tertiary carbon, CH3, CH3, CO, and a H. This is one of the reactants. And I'm just going to open up this carbon. So CH, H, and another H, CO, CH3. Now this one reaction with dilute sodium hydroxide is going to give us the product. So here what happens is this hydrogen, this is just, I'm not talking about the mechanism. I'm not saying anything about the mechanism, but basically okay, just assume that this hydrogen is going to come and form a bond with this oxygen. Okay, so it breaks off over here and forms a bond with this oxygen. Then now oxygen has 3 bonds. That's not okay with oxygen. So it shifts off over here. Now carbon just has 3 bonds. It's not okay with that. And so this carbon forms a bond with this carbon atom. And that is how you have the formation of the product in this reaction. So you get CH3, C, CH3, CH3, COH, H, C, H, H, CO, CH3. And this is going to be our product. Now, the reason I'm not going forward with the elimination of a water molecule like so and having a double bond between these 2 carbon atoms is because they haven't mentioned the fact that there is, that step has happened. So they're just mentioning that, it reacts in the presence of dilute NaOH. And so we stop this reaction over here. The next one is our compound is reacting with HCN, that is hydrogen cyanide. So CH3, C, CH3, CH3, COH is reacting with HCN. And this in turn is going to give us this particular molecule where you have O minus and Cn attached to this one. So CH3, C. And I believe this particular reaction is just a direct reaction from your textbook. So CO minus Cn and a H. And this further going to get rearranged, or it's going to, the hydrogen is going to get attached to this oxygen atom for us to get an OH group attached to the carbon. So CH3, C, CH3, CH3, COH, Cn, and a H. So valency is all taken care of. The last one is concentrated sodium hydroxide. So when you have a concentrated sodium hydroxide, this is actually a named reaction, that is Canizaro's reaction. So Canizaro reaction, what happens is you have, let's say, for example, we have this particular molecule, and this is reacting. So we have 2 molecules of formaldehyde. This is a basic reaction for Canizaro. So these 2 are reacting with concentrated NaOH, and on heating, it's going to give us an alcohol and a sodium salt of carboxylic acid. So we're going to get HCHH and an OH plus a sodium salt of carboxylic acid. So HCONA. Okay, now we're going to apply this particular reaction to the or we're going to write this reaction for the compound that has been given to us. So CH3, rise CCHO plus CH3 rise CCHO plus concentrated NaOH on heating is going to give us an alcohol and a sodium salt of carboxylic acid. So CH3, so one of the aldehydes is going to get converted to an alcohol. So COH, CHOH plus CH3 thrice CCOONA. So with that, we're done with this particular question. The next one is this question number 36. It's the last one in this that we're discussing for this particular paper. And I mean, I think this is the other part of this question. That is, this is the or part of the question. The other one did not have any chemical reactions that they asked about, so I'm not discussing that in this video. So let's start. So they've given us this particular reactant, a very, very important concept that you learned in organic chemistry is the diazonium salt, and the reactant is a diazonium salt. And if you look at the reagent of this particular reaction, it's CuCN, which is, and this is automatically, I think you should have realized this by now, that it's a named reaction. So C6H5, and yes, I like drawing the benzene rings. So N2 plus I need to draw these. Anyways, so this on reaction with CuCN is a very well-known reaction. It's the Sandmeyer reaction. And this is going to lead to the formation of, or rather, it's going to lead to the attachment of a CN, that is a cyanide group, to the benzene ring. And our other product is nitrogen. And now this is undergoing a reaction with H2O and H plus. So this is again it's actually the preparation of carboxylic acid from nitrile, and CN is the nitrile group. So in that reaction, what is happening is we have RCN, this on reaction in the presence of H plus or OH minus, and H2O is giving us RCONH2, which is an amide. Not an amine, an amide, because of the CO group attached to it, because of this group. Now this is again further undergoing a reaction with H2O/H plus and heat to give us RCOOH. In this case, the R group for us is the benzene ring. So they're not we're not concerned about the amide itself. So the final product of this reaction is going to be the carboxylic acid. So this particular question might seem a little tricky because we're considering two different units. Like the diazonium salt is from the chapter amines, and it's a Sandmeyer reaction. That was a direct, it was just you recalling the fact that you've learned this and you just had to write this down. But the conversion of the nitrile to the acid would be slightly tricky, but you can get there. You can just write down all the chemical reactions, write the reactants, write the products, and just the reagents, like have separate columns, and then go through them every day. You'll be able to recall all of these by the end, or by the time you have to appear for your boards. The next one is CH3 COOH acetic acid is reacting with NH3 and is getting heated. So when this particular reaction takes place, it's a carboxylic acid, and it's the reaction of carboxylic acids with ammonia, that is the NH3 group. So in carboxylic acid, so I'm going to write the whole reaction down here. So in carboxylic acid is undergoing a chemical reaction with ammonia, it's leading to the formation of something called as the ammonium acetate. It's forming the ammonium acetate. So CH3, COO minus, and NH4 plus. Now this further on heating is going to, is leading to the elimination of water molecule and leads to the formation of a CH3CO NH2, which is again an amide, and this specifically mean is acetamide. So this is product A. And the reason we're considering the entire reaction is because they've mentioned both ammonia as well as the heat. So CH3, NH2 is our product A. Now, this is undergoing a chemical reaction with NaOBr. Oh, this again, I took some time to figure this one out. The reason being, when you read this particular reaction, or when you have this particular reaction in textbook, it's NaOH plus Br2, which gives us NaOBr. But it took me a while to realize that. Again, I think this happened with another question as well for, I think, set 1. And this is the Hoffman-bromamide reaction. So Hoffman-bromamide degradation, what is happening over here is you have an amine, RCONH2. This particular molecule on reaction with NaOBr is going to give us RNH2 plus Na2CO3. Actually, the byproduct would vary because I am specifically talking about this. So, and we are only concerned about this particular product. So basically, an amide is getting converted to an amine, and you have the loss of this CO carbon. So the product for here is going to be this CO is going to get kicked out, and the product is going to be CH3NH2. So we have an amide getting converted to an amine, and this is product number B. And the next question, the last one for this paper, is write the write the chemical reaction of methylamine with benzoyl chloride and write the IUPAC name of the product obtained. So let's write the reactants that they've given us and then go from there. So they're talking about methylamine, which is CH3NH2. And this is reacting with benzoyl chloride. So benzene ring and COCl. So these two are reacting. So what should the product be? Now, this is actually the acylation reaction of an amine. And I'm going to write the basic reaction down here so that it's easier for you. So let's, for example, take an ethyl, or let's just take this methylamine. So CH3NH2, or right. Now, when you have a COCl, and let's take a CH3 here. So this lone pair of electrons is going to come attack this carbon, and this double bond is going to shift upwards. And this is in the presence of a base. And this gives us a C2CH3. Nitrogen will land up having a positive charge because NH2 and a carbon atom attached to it. So let me put that there. You have a negative charge for the oxygen atom because electrons. Then you have a CH3 and then you have a Cl. So we have a nitrogen with positive charge and the oxygen with a negative charge. So what this hydrogen atom decides to do is, okay, it's like, you know what, I'm just going to do this, and it just this, and the Cl gets removed. So two things are happening. Hydrogen is getting removed, chlorine is getting removed. So you have HCl, and the oxygen figures, okay, this is my chance, and forms a double bond with the carbon atom. And so you get the product CH3, nitrogen, and the hydrogen over here, CO and CH3. Now, the same thing, the same reaction can be applied to this one as well. So what's going to happen is you have the CH3 group is going to stay the same. So CH3, nitrogen, stays the same, hydrogen, again the same. Now, over here, CO, okay, because this is carbon, this is the carbon atom. And then to it, this benzene ring is attached to it. So this is going to be our product. And the name of this compound is N-methyl benzamide. With that, we're done with the questions for set 2 in this paper, or rather set 2 reaction-based questions. I hope this helped you out. Do check out the other videos which I did for set 1 and sorry, this is set 3. Set 3. So check out the videos of set 1 and 2. Hope this helps. Keep checking out, go back to chemical reactions, keep learning them again and again. And only with that will you be able to solve such questions in the exam. All the best.